Hello everyone, let's discuss about holographic principle and Ads CFT correspondence. In this video, we'll discuss about black holes, information paradox, the basic idea behind holographic principle, AMS paradox, black hole firewall paradox, vacuum entanglement, Ads CFT correspondence, and an idea called ER equals EPR, that is quantum entanglement. And wormholes might not be different, after all they might be same thing. And space-time from entanglement, that is quantum entanglement, might be the reason for the existence, for the smooth existence of space-time. And dark energy proposal, that is how dark energy can be explained, mysterious dark energy can be explained through quantum entanglement. Let's discuss about this. But before jumping into the video, I need to say one thing. The fifth topic, vacuum entanglement. Let's just say that if you take a chunk of space and you divide it into two halves, you can say that the left half of the space and the right half of the space get entangled. We'll see more, we'll look into that, but just remember this. Entanglement, we thought entanglement was for particles. How can empty space get entangled? But let's remember that even empty space consists of quantum fields. So even quantum fields have many degrees of freedom. Those degrees of freedom can get entangled. We'll see deep into this vacuum entanglement, but let's just keep it in mind before we jump into the topics. Black holes are beasts of cosmos. They have very high gravitational pull, and there is a point of no return called event horizon. Once you cross the event horizon, you can't come back. And there is a sacred law, you can say it a sacred law in physics called information conservation. Information in the universe cannot be destroyed. What am I saying? Suppose I take a piece of paper and I write most important physics equations, say, and then I burn it and I have nothing but ashes left, ashes and smoke. All the information has gone away. And if I ask some person, what are the equations I have written, can he tell from ash? No. But theoretically, it is possible. If I can get back all the ash which has gone into the atmosphere, and all the smoke that has gone into the atmosphere, and the ashes, if I arrange every molecule, then I can recreate entire paper. So information cannot be destroyed. This is kind of a sacred law in physics. But black holes posed a threat to this sacred law. Let's see how. Suppose something fell into a black hole. Black holes don't just take stuff in, they even evaporate. Stephen Hawking showed that even black holes have death. They radiate, and after some time they die. So even black holes have some time, expiration date, if you will. But before that, black hole, there is a theorem in black holes called no-hair conjecture. That is, all the black holes can be described by only three parameters. Any black hole can be described by only three parameters. That is mass, angular momentum, and charge. So suppose, let's say, a person of mass m has fell into a black hole, and another person of same mass m has fell into another black hole. Now these two black holes have radiated away, okay, through Hawking radiation, and nothing has left, only thermal radiation in the air. Now I ask you, which person jumped into which black hole? How can you tell that? We can't tell, because whatever has come out of the black hole, Hawking radiation, it's just a thermal radiation. You can't detect a pattern out of that. So all the information has been lost. So this posed a major threat to the conservation of information. But the Ads CFT correspondence gives a solution to it. Suppose, consider this. There is a person called Alice and a person called Bob. Alice is in free fall. He's falling into a black hole. Bob is observing Alice. We know that as close as you get to black hole, time starts to slow down. Time dilation is very, very high. And near to the event horizon, it's like a break to the time. Time doesn't even flow. Events don't happen. So from Bob's point of view, Alice falls into the black hole, but slower and slower. He never reaches into he never crosses event horizon. He just sticks there at event horizon. You can say that he becomes a paste. He becomes tapered to the event horizon. He doesn't cross event horizon. But from Alice's point of view, he'll just go into the black hole. He'll fall into the black hole, hit the singularity, and dies. So everything happens for him in just 5 minutes. But for Bob, This is it takes millions and billions of years. So they experience two different realities. This is because of time dilation. But let's move on now. So if what happens to the information of Alice? Yes, he's made up of many quantum bits, right? He's made up of many quantum bits. What happens to his information? Let's see. Suppose we can represent Alice as in terms of zeros and ones. He is composite of many bits of information. Now Alice is going into the black hole. As we can see, all of his information is being pasted on the surface, is being pasted on the surface, and entire information just sticks to the surface. The surface of a black hole, event horizon surface, is two-dimensional. You have to keep this in mind. Now let's see. We can say that entire whatever all the experiences of Alice inside the black hole, all his gravitational experiences can be described in a non-gravitational way on the surface of the black hole. That is, gravity in 4 dimensions is equal to no gravity and just a quantum field theory in a 3-dimensional surface. This is a 4-dimensional surface is being projected from a 3-dimensional surface. This is like a hologram, right? All the gravitational and quantum mechanical information inside the black hole can only be described by quantum field theory at the boundary. This is a duality. It can be either described by gravity or it can be described by quantum field theory living on the boundary. So entire information of the black hole can be described at the boundary of the black hole. You can see from the third picture, all the information is just being pasted at the boundary, and eventually Hawking radiation will just get entangled to this information and carries away it into the space. So information doesn't just disappear, it comes back to our universe. So information is conserved. But this idea of holographicity has given rise to ADS CFT correspondence, one of the greatest theoretical results. It's most cited paper in entire physics, not even Einstein's 1905 paper. This is the most popular paper. Now, holographic principle, just like holograms, information completely on a 2D surface is projected onto a 3D hologram. Okay, this is holographic principle. But before moving on, let's just revise about quantum entanglement. Quantum entanglement is a phenomena where two particles share a same existence. That is, the evolution of two, even when they are separated by millions of miles, millions of light years, they share same existence. That is, the evolution of particle 1 depends on evolution of evolution of particle 2. All the probabilities or the results of particle A depends on particle B and vice versa. So they are not independent. They are correlated. Even when they are at the opposite end of the universe, if you make any change to particle 1, it gets instantaneously reflected upon particle 2. This is a mysterious phenomenon of quantum entanglement. So this is faster than light, theoretically. We are still looking into it, many physicists, but we have conclusive proof. There were like 1,000 tests to prove that quantum entanglement exists. So quantum entanglement is way faster than light. Let's consider a scenario. Suppose Alice and Bob have two entangled particles. They carry the entangled particles and they move away, far away. So let's say many light years, and Alice has crunched those all particles into Schwarzschild radius and he forms a black hole, and Bob does the same thing. He crunches and they form a black hole. Now we can say that black hole of Alice and black hole of Bob are quantum entangled, right? They are entangled. Now suppose consider the regions 1 and 2 and 3 and 4. Now we can say that I just said, asked you to remember that even empty vacuum has entanglement. So 1 and 2 has an entanglement relationship, and 3 and 4 has entanglement relationship. But this violates a sacred law in quantum mechanics, that is monogamy of entanglement. That is, entanglement can occur degrees with only 2 degrees of freedom, but you can see that 1 is entangled to 4 as well as 2 as well as 3. So this violates monogamy of entanglement. It should be only either one should be either entangled to 2 or either entangled to 4. But how? Because this was Am's paradox. So how can we resolve it? there was a suggestion that inside of a black hole does not exist. There is a firewall, something like just like in software, which blocks inside of black hole. Only 2 and 3 exist in the world. 1 and 4 are just in the papers theoretically. But this didn't seem right to the physicists. It was unappealing. Later on, there was this idea: what if 1 and 3 regions and 2 and 4 regions are the same? What does that mean? 1 and 3, 2 and 4 regions being the same? It seems stupid, but there's a way around this. Wormholes. Wormholes are Einstein-Rosen bridges. Wormholes are like portals in movies, which is a show, Doctor Strange. They are like portals. They connect two regions of space-time. If you have seen Interstellar, it gives you a clear idea. What we are saying that if there is a wormhole connection between these two, then the Am's paradox is resolved. This means two entangled black holes is nothing but a wormhole. So wormhole is nothing but two entanglement black holes. What's entanglement? Einstein wrote about it, EPR. And what's wormholes? Einstein wrote about it in 1935, the same year, Einstein-Rosen bridges. So we have seen that Einstein-Rosen bridges and Einstein-Podolsky-Rosen might be the same thing. ER equals EPR. Now let's jump into ADS CFT correspondence. ADS stands for anti-de Sitter space and CFT stands for conformal field theory. It means, and correspondence means there is a direct relationship between anti-de Sitter space and conformal field theory. But what is anti-de Sitter space? Anti-de Sitter space is one of the space times with negative cosmological constant. It's a hyperbolic surface. You can see from the picture in the left that as you move towards the boundary of anti-de Sitter space, you can't reach the boundary. You get closer and closer and closer, but you can't reach the boundary since the tessels at the boundary are infinite. They become infinite. This topic is not important, but you can see that anti-de Sitter space is an infinite, but at the end there is a boundary. Okay, there is a two-dimensional surface to three-dimensional anti-de Sitter space. I'll explain about it in detail, but let's see this. Anti-de Sitter space, this ADS CFT correspondence, it can be also called gauge gravity duality. It was proposed by von Maldacena. It says that gravity in three-dimensional universe, 4 dimensions if you include time, gravity in three-dimensional universe can be described by only quantum field theory in two-dimensional surface at the boundary. 2 plus 1 if you include time again. So you can see that all the information in the bulk, the three-dimensional surface includes gravity, can be described by a quantum field theory at the boundary which doesn't include gravity. This was just like we saw in black holes. Black holes at the surface, all the gravitational information inside the black hole could be described by non-gravitational quantum field theory at the boundary. So it may be similar to that. Our universe, which we feel with space-time curvatures, gravity and everything, can be described by a non-gravitational theory at the boundary. This is like a hologram. At the boundary, the information encoded at the boundary in the manner of quantum field theory has all information about the three-dimensional surface we live in. So all the information in the three-dimensional surface can be extracted from the two-dimensional surface at the boundary. It is like we are a hologram. Many scientists compare it to a balloon. The inside or the three-dimensional surface we live in is called bulk, and the surface of our three-dimensional world is two-dimensional, right? It is called boundary, bulk and boundary. Okay, just like a balloon and its surface. ADS CFT correspondence also helps in studying strongly coupled quantum field theories. Now consider this. At the boundary, we have a Feynman diagram of say 2 gluons. It's a very strongly coupled and a very complicated Feynman diagram at the boundary. But if you look into the bulk, it's a Feynman diagram of 2 gravitons scattering. So we can say that it's a simpler calculation. So this is a great mathematical result also. But let's see the current animation. Three-dimensional surface. Consider this is a gluon and it is its world sheet, gluon's world sheet. It forms a semi-spherical surface. We can also view it as graviton escaping out of the membrane. So same world sheet can be explained by gluons and gravitons. This is a basic idea behind ADS CFT correspondence. Gravity in 4 dimensions is equal to quantum field theory in 2 dimensions. or 3 dimensions if you include time. Now let's study about vacuum entanglement. Consider our space-time and let's draw imaginary line between that. At the two sides of the line, let's draw some tessels or small tiles. Now the smaller circles and the bigger circles and the even bigger circles get entangled. Why they get entangled? Because you see the empty space-time is not just empty, it is buzzing with a quantum activity. It has many quantum fields. So the tiny tessels, the big tessels and tessels, these tessels represent regions of space-time. So regions of space-time get entangled. But what regions of space-time get entangled for? You can say that the probability of finding a particle. So that is, suppose you find a particle in the region in the left, circle in the left, you would find a particle in the region in the right. So this is vacuum entanglement. Now there is an idea which was proposed by Mark van Ramsdonk. It's that see now from this vacuum entanglement you can say that theoretically if you remove the entanglement, the connection gets loose and it's like tearing apart. It means space-time gets torn apart. It is like space-time is got stitched by quantum entanglement. Quantum entanglement is stitching space-time together. So it is quantum entanglement might be the reason why our smooth space-time exists. And Mark van Ramsdonk idea is that our three-dimensional surface, entire space-time, is built by quantum entanglement of degrees of freedom at the boundary. It means the quantum and all the events here, the evolution, the surfaces, entire thing can be equal to the entanglement of quantum bits at the boundary. But what happens if we remove the entanglement? If we remove the entanglement, the space-time gets torn apart, just as we saw in vacuum entanglement. If you remove the quantum entanglement at the boundary, the bulk gets torn apart. And if you completely remove the entanglement, the entire space-time, it just gets destroyed. So there is no space-time. So quantum entanglement at the boundary might be the reason why we are having such a smooth space-time. So quantum entanglement, which Einstein called the spooky action, is the reason why our universe exists. And I promise that I would talk about the dark energy idea with ADS CFT correspondence. It basically says that dark energy is causing the expansion of space-time. I'm just speaking here roughly. Something which causes the expansion of space-time. So we don't know why it causes what dark energy is, but it causes the expansion of space-time. But you see, our space-time can be described by quantum mechanics on the boundary, right? The quantum entanglement has an evolution over time. As it evolves over time, the quantum complexity at the boundary increases. This is analogous to increase in the spatial area of our space-time. So ADS safety correspondence may in some day explain about dark energy. There is a research going on, but we are not completely sure. Thank you.